All right, guys. Welcome to CTIS-12. I will be your instructor for the duration of this course. I realize my mic is way far to my left. My name is Al Adame. You can call me Mr. Al, Mr. A, Professor Al, or just Al. I really have no preference for titles or even Mr. Adame. It doesn't matter. Whatever you're comfortable with, I'm cool with it either way. So I am re-recording this part of the lecture because unfortunately during our first class meeting, it didn't save. So guess what I get to do now? Re-record everything we went over. So I'll start, other than just introducing who I am and my name, a little bit about myself here. I have been teaching for Merced now for about 3 years. I usually teach this class, CTIS-17, which is Windows administration, Linux administration, and a little bit of server administration and networking. It's all combined. That's usually in the spring, which is coming up if you want to sign up for it. Be my guest. It'll be similar to this class in terms of format. It'll be online. I don't know the days yet, but I know it's going to be in the spring. I also teach CTIS-22, which is digital forensics. It's usually offered in the spring, but to my understanding, this spring it will not be offered. That's where we dive into how to recover data off a flash drive that's been erased, how to do RAM captures, how to be running cases in terms of like for a police department or an organization, how to do a forensic digital investigation, how to set up a lab for that specific task, and things like that. But in this class here, CTIS-12, we cover servers. But I'll get back into that in just a second, a little bit more about me. Other than teaching here at Merced for 3 years, I also work at my local community college here by the House of Mouse. I live in the city called Santa Ana. I work at the College of Santa Ana. It's my alma mater. I got my A's from there as far as my education goes. I have a master's in cybersecurity, a bachelor's in information technology, an AA in computer information systems, and an AA in communications. So I've been around the block a little bit when it comes to all this stuff, but not trying to toot my horn or anything here. Just saying you're in good hands. But guys, treat me as a resource. I'm here to help you. You need help with your resume. You need a letter of recommendation. You feel a little lost, even you want to talk to somebody. I'll share a little bit more about myself in that regard. I was originally going to a college called OCC over here for 2 years. I got kicked out from there for not having good grades, not doing well. Even I felt a little lost. I went over here to Santa College. I spent like another 8 years there. Believe it or not, so it took me 10 years to get out of community college. But I mean, look at where I am today, sitting in front of you now, just teaching and lecturing. So, and oddly enough, I also work for the Golden West College. It's part of the OCC college system. So I get to see the counselor that told me I never amount to anything every now and then, and they just, shy away. So it's kind of like, hey, I made it. You were wrong. But that's not the point. What I'm getting at is if you feel lost, you're like, man, I'm not sure if this is what I want to do and all that, talk to me. I can maybe give it a different point of view, or you're like, hey, I'm trying to break into, the IT world here. Well, how should I go about it? Like I'm education, or what else can I do? Again, that's like the information I can help you with as much as I can, or point you in the right direction. So without further ado, let me redo these lectures and I will post them by this Sunday, which today's Friday and I'm recording it early. So you guys are lucky I got to redo this. So let me start from beginning here. So, actually, no, those are the wrong slides. I need to start with the basics of networking because this is just a refresher. Don't worry. This is just so you guys can kind of get up to speed and be refreshed. So we're going to start with networking because networking are the fundamentals, in my opinion, of almost everything when it comes to computing and sharing resources and doing things. Networking, networking, networking. Why networking? Because it's like the backbone of everything, right? Your cell phone's on a network. Be it your home network, a cellular network, it's still a network. GPS runs a network, a GPS network. It's all interconnected. So it's a network of things, items. So don't worry about the date. This is a little old, but the information hasn't changed much. So let me dive into this here. So it's covering for this for right now. It's just this. This is what we're going to be getting into in these slides. So why do we network? IP addresses, what's a MAC address, what are ports? There's two kinds, physical and digital. The OSI model, what it's used for, TCP/IP, what it's used for, network topologies, which I'm going to go over, and IPv4, which is actually, I think it's mentioned somewhere in OSI models or before. It's somewhere in there. It's unfortunately out of order, and I do apologize. So my main question to you is, why do we network? Well, yeah, to get data from one place to another is the real reason. If you're at home, you have a network printer like you're showing here, and you want to print something, the printer might not be next to you, might be in the living room, kitchen, backyard, or somewhere, and you can print to it, even from your phone if it has Bluetooth. You can print to it, right? Connect to Bluetooth via the printer, tell it to print, and it prints. You're networking, you're sharing resources. That's the whole reason. And I mentioned this in lecture prior, so I'll mention it here again. When it comes to questions and midterms and everything else, I know AI exists. I know you're going to use it sometimes to help you get started and figure things out. That's fine. But please, 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 please do not rely on AI to answer everything for you. It will be there in the real world when you're working. I understand that, but it's not your definitive answer. If I ask you a question, like if I were to ask you, why do we network? And you copy and paste it into ChatGPT, Gemini, or whatever, and it spits out this really long, complex answer, and none of it has to do with anything I mentioned on the slides or I even talk about in these lectures, why is it on the test? Why are you even answering with that? I can tell when it's AI. Trust me, I know how you guys write. And that's just because you used AI. And if it's just out of character, I can totally tell. So please, this is my warning. Don't do it. If I catch you, you'll get a 0 in the exam. I'll have to fill out paperwork. And then you're going to go see the dean of academic affairs. And then that's not a good time for anybody. Okay. It's not the one thing I like to do. It's just, I'm warning you guys. I've been down that road. It's not fun. Then we have really uncomfortable meetings between you and me. And I don't like to be the bad guy. I don't want to be the bad guy, but sometimes you guys force my hands. But back to this. So just that's a warning. So we network, right? To get data from one place to another, to do things, you're on the network here. This computer is connected via wireless, then it goes to the internet. The internet's a resource, right? The internet's not this big magical thing. Used to be. It's the web of interconnected computers, right? Just sharing things, sharing items, sharing websites, sharing YouTube, Netflix, anything you need is on the internet. I'm sure you've heard that saying before. Also, don't believe everything you read on the internet either. So that's part of it. But that's why we network. So let's move on real quick here. I might fly through all of these. I'm sorry. Just it's talk about this stuff most of the time. So let's talk about an IP address. Let me pull up mine from my computer, and I'm going to show it to you. So it's okay. You can have my IP. It's not going to break anything. Sorry, I had to remember the command. I do this all the time, but it's not always going to be in the forefront of my mind when I'm talking about it. So this is what an IP address looks like from a desktop's perspective. I'm going to put it here. So that would be it right there. And it says preferred because that's what I always get assigned to it. The reason I do it that way is in case I need to do what's called pathing. Pardon me. If I need to path to grab a file, folder, or whatever, if I'm on a laptop, like somewhere in the house, I need to do something, I can just go to my computer and grab it. But that's my IP address there. That's what that looks like. It's unique. If another system were to come online, let's say hypothetically, another laptop, and it tries to use this IP and it say gets assigned or given to it, like a unique house address, they would both do crash. Well, what happens when both two computers have the same IP on the network? The older computer, which would be my personal computer on this instance, will get dropped and the new one supersede and take its place. You can never have two IPs on the same network because they crash or conflict, and they always drop the quote oldest version if that makes some sense. So an IP address has two components: a network component and a node component. Think of it as your house address plus your street name, which is true. So, 123 is the network component of it. Then King Street would be the node component, which is the tail end of it. That's essentially the best way to think about it. It's pretty simple, right? Every house has a unique address, right? There's no, I don't know, 123 King Street, then 123 King Street again. No, it'd be 456 King Street or what have you. So the other differentiating item is what's called a MAC address. Well, on a computer, a MAC address is this. Refers to physical address. Well, why is it called physical? This is stamped onto my motherboard on my network adapter Ethernet port on the board right under where the connection is. You can see it in white usually. So, well, what's that stand for? It stands for Media Access Controller, a hardware identifier that uniquely identifies each device on a network. It is a unique identifier for any device. The MAC address identifies the device to other devices on the same local network. So, for example, this GRAN router, it's pretty old, but look, its MAC address is completely different compared to mine. Mine is, there we go, D8, this one's 586D8 FCC AA7CB. Door just slammed, don't worry about it. So mine's completely different. So sometimes, and this has happened, you will have the same MAC address or rather a duplicate MAC address is the best way to put it. I could have this like on something else. Let's say I bought a a wireless card that came with it. You'd be like, oh no, what do you do? Normally what they do what's called unbranding and rebranding. So it requires a special kind of bench with some special computer software. And bench, I mean like a computer you can plug things into. They would plug it in and they would have software that would unbrand or what's remove that hardwired MAC that's coded in also to the board, remove it, assign it a new one, and then just restamp the board with a different MAC or that new MAC address they gave it, and that fixes the problem. If you have something that has two MAC addresses on the network will get confused and drop one, which would usually be the older one, like it will with an IP. So let me move on here to the OSI model. So the OSI model is made up of 7 layers. Now, the OSI model isn't something you're going to be just using every day in sense of, oh, well, oh man, I need to network this computer next to me to that printer. Let me consult the OSI model like if it was a roadmap. No, it's not technically a roadmap. If anything, it's more like guidelines. Well, what do you mean for troubleshooting? So let's say you are surfing the internet and you can't reach YouTube. Well, I can't reach YouTube. Let me check all my stuff. Let me start with my physical connection. Is my network cable plugged in? Okay, yeah, cool. Are the lights on? Are they blinking? Green and orange. Okay, cool. Now let me check the router's settings and see where I'm at. Let me check the data link and the network and so on and so forth. Let me try to ping it. Let me see if I can even ping a website. Give me a second. So you know you can ping websites, right? I'm sure most of you know this. If I go to ping, I'm gonna try Yahoo just for the sake of trying it. Oh, it's getting back to IPv6. That's really big. What else can we ping? Oh, let me think of something. I can't do CNN probably, but just trying to think of live websites. So yeah, see that gives you an IPv6 too. But yeah, it responds back. If I were to take this in the browser, it might even take it to the website. But normally it should give you an IPv4 version of website address. Oh, I'm trying to think of another good live one we could use. That's okay. Not the end of the world, guys. But just showing you, you would just test things. This would be within the router. That's connections between the back and forth. So that this is what establishes the connection between the website and you. So that will be a session, air quotes, it's active. Then this data is presented between everything. And lastly, this is Chrome, Firefox, Edge, and you can even say to an extent Internet Explorer, it lives here. So if you're having issues, you would just use this to troubleshoot. I also made it colorful over here. Burgers. Who doesn't like a burger? And I apologize if you're a vegan. I didn't mean to offend you or anything. To replace the meat patty with like vegetable patty. Maybe I could do pizza next time or a big 7-layer cake. But that's everything just in burger format. So, this burger has seeds, has onions, sesame seeds, tomatoes, pickles, or a session layer, cheese, your transport layer, and network layers, your burger patty, your data link layers, your lettuce, then ketchup is your physical layer. So it just layers up. That's all it's for. But remember, there's always 7 layers. There's also a couple other ways to, what was it? Don't throw away. Hold on. It's gonna bug me if I don't know what it is. An acronym for it, and it's hold on. It's come on, love. Yeah, it's please do not. So it would be please do not throw sausage pizza away. That's what it is. Yeah, that's how it was. It's been a while, so I don't remember the acronym. I don't use the acronym that often. I just reference the layer when I need to. So, if you're having network issues, just go through the layers until you figure it out. It's more just a troubleshooting guide. That's all it's for. So let's move on. If this doesn't work for you, tell me. We can have a one-on-one. I can explain things a little further. Whoopsie doodle. Is that the next one? Hold on. Did I just break it? Oh yeah, we're on ports. Sorry, my mouse caused that. So there's two kinds of ports. There's a physical port. I'm sure we've all seen this. It's an Ethernet port. You got a PS5, an Xbox, a TV, a computer, a laptop, even though some of them don't come with these anymore. What else would have a network port? It's pretty popular off top of my head. Fridges have Wi-Fi now, so it won't be a fridge. I would argue TVs. TVs have them now, but that's a physical port, right? So we plug it in. But there's also digital ports. There's a host of them. This is the digital ports that are open on a network usually. Port 20 and 21 are pretty common. It's for transferring files. That's why it's called File Transfer Protocol. Don't worry, we'll implement something like that. Port 22 is used mainly for tunneling and creating secure network connections. Port 25 is for SMTP, which is Simple Mail Transfer Protocol. It's what handles emails, back and forth communication. Port 53 is for domain name services, DNS. It's what essentially converts the domains of www.google.com to IP addresses that are readable between peers and back and forth. That's what it handles. Port 80 is for HTTP. It's what makes the World Wide Web possible. That's how the internet works and runs on that port. Then the rest all offer different things. So another thing about networking that I did forget to mention, I didn't think about gateways that much, but I'll get to it right now in a second. There's no slide for it, but part of it is just information for you guys to have. So TCP, or Transmission Control Protocol, this is a guaranteed way in which two computers can talk to each other. It's the way most communication in the internet is sent. So it's like a handshake. Like, hey, I'm computer A and I'm server B and I'm trying to get to CNN. Okay, let me talk to server C, get CNN, shake their hand. Okay, we have everything cool. Let me send it back to the computer A and shake their hand. Like, here you go. I'm guaranteeing you're getting the information you need. That's what it's for. So as I've stated before, every computer has a unique IP. It's what allows things to communicate between each other, and they send something called a data packet, which travels back and forth. This is what a data packet's made out of. Has a destination MAC, where you're trying to go, source MAC, which would be you, destination IP address, your source IP address, the payload, which would be your website, item, whatever, and CRC, something stands for redundancy control. Um, Computer redundancy control, off the top of my head. It's been a while. Give me a second. I should have a note about it. Yeah, cyclic redundancy check. Sorry. So this is what checks for errors in the payload when it gives it to you. So let's say you're trying to pull up a website and just a part of it comes out wrong, like misshapen or didn't load correctly. It will check it back in the CRC, send it, hey, I need this part of the packet again, send it back. It'll send it right back to you, and then they'll fix the error in your stain loads. Normally, you have this nice fun website in front of you. So what was I getting at about IPs right now? Yeah, see these all got converted when I pinged them to an IP address. And they replied back. This is all because of DNS. That's how that worked. So I know I'm going through this a little fast, guys, but it's just should be just a refresher. So don't worry. So let me move on here. So IPv4, I'm sure you guys have heard that we're running out of these kinds of addresses. That's what's kind of making the need to go to IPv6, which will happen over time, like 10 years, but we're not going to go anywhere anytime soon. So IP addresses are 32 bits long because each set is made up of something called an octet. Each number in it is an octet. So we have four octets, and each octet is normally described as in decimal numbers. So that's how you get 192 dot whatever dot whatever dot whatever dot whatever. 8 bits of data or a single octet can represent all decimal numbers from 0 to 22. So your range should be 0 to 255. Sorry, not 22. And you can be anywhere in between. You can have one, two, three, it can go on and on and on, right? Then you have a second set, then a third set, then a fourth set. Those can all be different. But this is what it looks like, right? This is what IP address looks like. This is an old IP address I had. Subnet mask, this is used in conjunction with IP address so that your device understands which subnet it lives on and used for routing outside of your subnet. Don't worry about it. We won't get much into it. So default gateways here are pretty unique. Every IP address ends in .1, so it could be 192.168.2.1. It's reserved. Oh, what do I mean reserved? You never use this yourself. You'll never get it. The gateways are what's on the router. They're assigned to that, and only they get those. Let me pull up my. Hold on. I didn't do it in this window. Oh, dang it. Of course it's not working, right? Hold on. Just let me pull up my IP configuration so you can see my gateway. And that's assigned to my router by the internet service provider that's reserved for it. Gateway, gateway. And of course, it's not showing my gateway. Oh, that one. Oh, my IP gateway is actually there. It is. See, .1 shows two types. It also matches my DNS, which is or DHCP, which is Dynamic Host Control Protocol, which is interesting. But then those two matches. But that's based on my ISP. I don't control that. Here's the IPv6 version of it, which would technically be end in dot or semicolon one. I don't know how to convert to those yet. I haven't learned. They're a pain in the butt. So that's what allows your router to talk to the outside world. That's how you get to the internet and do things. So let's move on and get into topologies. These are still used in labs and business areas. So you have a couple. Plus topology, it's cost effective for smaller networks. Like think of a small office. They would run like this, right? You would start with the router over here somewhere or the server, then it all goes in one line, then it spreads out to be used by different machines. Get connected by a single cable. It's effective, it's cost effective, it's cheap. So that was more popular back in the 80s. You still see it from time to time. And back in the 80s, this is how they used to network. I'm going to show you what it was called or what it was used. It was called a vampire tap. And the reason it was called it a vampire tap is this is what it looks like. What's that? Uh, so this right here, it got it off Wikipedia, was the first kind of networking. Don't worry about all that stuff that's on. That's what it looked like. It's not the best picture. Let me pull up one that's actually doing its job. Give me a second. It's called a vampire tap because what do vampires do? They bite, right? So they would literally physically punch a hole in the cable. Yeah, that's a very good picture of one actually that shows how it works. Give me a second. It's not the greatest. Ah, it's too small. Sorry, guys. I'll find one. Give me a bloody second here. Come on, vampire tap. Okay, it's from a book. It's fine. I'm not gonna get in trouble. Where is the picture? Ta-da! Vampire tap. See? There's the network cable. At that time was coaxial, which is just one line of copper. And they would punch it, hit the cable inside. Then you would use this is called parallel. It's older or serial. Remember, right? I can't recall which one it was. And that would connect to your computer and give you internet. No, it's not like this. This is a mini vampire tap. It's a joke. Okay, it's not. It's not this. Okay, I'm just messing around. Okay, this is not technically yes, it is a vampire tap. It's not the vampire tap you're looking for. It's that one. That was the first kind of networking back in the 80s. But anyways, that was mostly used on bus. Nowadays, you mostly find star setups which run off of a network hub. Hubs can either be what are called dumb and air quotes for dumb. You can't program it. It just grabs what it needs off the network and assigns addresses or routes the addresses appropriately versus the smart ones, which you can program and tell to use only this range or that range and blah, 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 blah. Star topologies are common since they allow you to conveniently manage your entire network from a single location. Because each of these nodes is independent, connection to the central hub should one go down, the rest of the network will continue to function unaffected, making the star topology stable, secure network layout. So yeah, it's pretty straightforward. Let me move on to the next one. Where are my controls? The ring. Still see ring around every now and then. It's called a ring because that's how it works. It's a large network. It's arranged in a ring topology. Repeaters can be used. So repeaters are only used after the network signal drops to a certain extent. It's called attenuation. It's a fancy term for the network gets weaker after a certain amount of space or time. So back in the day, if you went more, I think, than 30 feet, your network signal will begin to drop and get slow, and that's when they would put in a repeater and it would mitigate the attenuation. Again, just a fancy way of saying it. Like when you have a wireless network, let's say your wireless network at home and you only go through one wall, you still get pretty good signal, right? But let's say you're wanting to get internet signal in your backyard, you go through four walls of a house, signal's fighting for its life to get through, and you will need a repeater somewhere in the middle that boosts the signal and sends it to out wherever it needs to go, and then you can connect. So that's what that's used for. Only one station on the network is permitted to send data at a time, which greatly reduces the risk of packet collision, making ring topographies effective at transmitting data without errors. By and large, ring topographies are cost effective and inexpensive to install, and the intricate point-to-point connectivity of the nodes makes it easy to identify issues and misconfigurations on the network. Sorry, I don't mean to burp so much. I had something that just probably didn't agree with me. So onto the last slide of this. It's called mesh. Looks really weird, right? Looks like some kind of alchemic circle, but it's really not. Everything's kind of interconnected. Mesh topology is intricate and allows us to have point-to-point connections where the nodes are interconnected, which I just did. Mesh networks can be full or partial mesh. Partial mesh topologies are mostly interconnected with a few nodes with only two or three connections, while full mesh topologies are, surprise, fully interconnected. Each machine's connected to everything technically because they piggyback off everything else. So there's pros and cons of this. Don't worry, I won't quiz you too much on it. But that's all I have for this part of the unit. We're on to the next part. So let me close this, admire my background for a minute, and I will get there. Let's see here. I'm going to talk about servers next. The first slide you saw in the beginning from this. So I'm going to talk about servers. What are servers? People that bring me food. They're waiters slash also called servers, but no, they're not. Servers in our world here is what we're covering. What is a server? How do servers work? Set up server requirements. This is set up a server in sense of like software. This is set up a server in terms of physical setup. Big difference. So let's define what a server is. A server is defined as a computer that is equipped with specific programs and/or hardware that enables it to offer services to other computer clients on its network. Hold on now. Is it working? Okay. Sorry about that. My headset decided to turn off for some weird reason. Now I'm back. But it's just a fancier computer that offers more services. Okay, pretty straightforward. Well, the precursor to servers were something called mainframes. Let me take you a trip down memory or history here, and memory lane for a second. So these were big old machines. Some of you may have seen them, some of you have not. Let me show you what they look like. The size of a fridge. Now they're the size of a fridge. They used to be the size of rooms. That's a newer version. I just want like a general one. I don't need the newest version. Just so you have an idea. There you go. That's what mainframes used to look like that. And they would run a software. If you've ever been to Costco, I say Costco because this is what it looks like. Look like this for inventory. It's made by Oh, that's not what I want. It's made by IBM. It's pretty common, but it was a lot back in the day for it's not the one I want either. Just trying to find a clean picture. There you go. It's used a lot for databasing. So let me pull this over. Things like that. See, you could do all this, and that was the early form of server. You would log in, run queries, run reports, print things. You remember the old dot matrix printers? They used to get print on paper with a ribbon. That's what these were used for back in like in the 80s. And believe it or not, mainframes are still around. They're still pretty powerful. They're used for that. But now they're mostly the AS400 systems not out to pasture per se, but it's mostly a relic technology. It's still powerful, still used. Like when the state does your taxes, it's done on a bunch of older mainframes like this, technically. And they should have replaced it about 5 years ago. They got the money for it. They haven't figured out how to replace it. So they're still working on it. So just know that that's still out there. If you ever heard of Cobalt, a lot of the Cobalt engineers retired a couple years, 5, 6 years ago. So that's what it's maintained on. Cobalt's a dead computer language. But anyways, back into servers. That was just a little tidbit of history if you find it interesting. I like to share those things. So I already told you what it's defined as. It just shares resources and information with computers on a network. It provides specialized software. It has specialized software built in or installed that lets it do a bunch of other things like manage users, maintain things. So how do they work though? Well, the most basic levels where you can type a URL in your internet browser like Chrome, Safari, Internet Explorer, or whatever replaced Edge. You can communicate with the server hosting that website to get the data to pull the sign up from the machine. So this is you, right? Hey, I want to go to, well, I don't know, Amazon.com, internet server. Hey, this person over here is requesting Amazon.com. Okay, let me send it. And then you get to Amazon.com. Essentially it. It just uses DNS to convert it from its name to IP and back and forth. From IP to name so you can see it on your screen and pulls it up. So then you can start your shopping or do what you need to do. So moving on. So what are server requirements? How do we set up a server? So this is the requirements for server 2016. They're not that heavy considering now modern day. I know most of you at this time have done the survey and you have more than enough space for all this. And you're fine. So minimum you need a processor with a 1.4 gigabyte core, 64-bit processor. Well, most of you have what's called the quad core and above. So you dedicate one core to it in the virtual machine, which I covered in the lab, which will be posted on Sunday. That'll be there. RAM, you have more than this amount of RAM. This is megabytes, guys. You now live in the world of gigabytes, okay? So don't worry. You're fine. Storage, only giving it 40 gigs, you'll be fine. All this we technically don't have to worry about because we're going to emulate it with virtual machine. I talk about it more in the lab, which will be posted. Don't worry, you'll be fine. So that's all the server requirements that you look on the packaging, just like you look at a video game, for example, or you're running a PC game, if you're a PC gamer, it tells you the requirements. So if you meet them or exceed them, great. If you're at the minimum, okay, it still kind of runs, you're fine. But that's the software portion of it, technically. So let's move on and figure out what else do we need to figure out? The hardware of it, like what are the guts going to be? What processor do I want? Do I want the drives to be swappable? How much RAM am I going to need? Oh, what else do we need to figure out? RAM, the video is already technically there, network port's there. What's its life cycle going to be? How long are we going to use it for? Things like that. What server OS am I running? There's a bunch of different ones. Do I want to do Ubuntu? Do I want to do Windows Server, which is now 22, R2? Do I want to run Red Hat? Do I want to run Sentry OS? So you have to figure it out. Heck, do I want to run Sun Microsystems OS? No, that thing's ancient. Just an example. So we got that much. Then location. Where's the server going to be? Am I going to install it in the wall next to the bathroom where the pipes, the water flow? Or am I going to put it somewhere they're conditioning? Am I going to put it in the break room next to the coffee pot? Like these are things you have to get figured out. So on top of that, you figure that out, the software you're going to be using. How do I want to configure it? So there's many ways to configure it, which you cover next. And then security. And what does it mean by that? Not just digital security, but physical security. So I always use this example in all my classes, so bear with me. So if there's a janitor, let's say wherever you work, and they vacuum all the offices, should they have access to wherever the server is installed so they can unplug it and plug in their vacuum to vacuum the areas around it? No, I don't think so. So it's things like that you have to keep in mind. But talking about server configuration, these are the common types. You can have a file server, a database server for the queries and running up different kinds, or spinning up different kinds of things, a web server to host a website, a mail server to handle email, a print server to handle printers. You can add our network shared resources, which I talked about sharing resources, right? That's one network. A domain server, which we will be creating in this class, so we can make a domain to add machines to, which would be the one virtual machine you're also going to implement. And an application server, so it can host a kind of program, like let's say, oh, I don't know, a food ordering system, That's you can have on there, and that's what they look like. So that's where the hard drives are, here at the bottom, little gray things. And this whole thing is called SCSI. What SCSI stands for, I have to look up because I forget. It's an acronym. But give me a second. No, I'll tell you what SCSI means. Means small computer system interface. Well, that's pretty uneventful. The thing about SCSI, which is nice about it, is you can hot swap. What does that mean? Pull that out, put it in a new rack or a new sleeve with drives in, and it'll write the data to it without causing an error crashing. That's hot swappability. That's part of the server as well. So let's move on here. I talk about OSs a little more. These are the kinds of OSs that are pretty common in the world. Windows Server, Essentials, it's just Windows Server itself. That's, what we're going to be running. Linux Ubuntu Server, we're not going to run because you could really break some stuff, so don't worry. It's not covered in this class that much. Red Hat Enterprise Linux, it's a paid form of Linux, which we also don't run. And then there's CentOS. These are just the most common, pardon me, and most popular ones that you'll see in the world out there today. Majority of the world runs Windows, but did you know, all enough, space shuttles, when we had them and whoever's replacing it now, the Falcon 9 or whatnot, all run on Linux and Ubuntu? Go figure. They don't use Windows for it. They use Linux and Ubuntu to handle all the tasks on board, which is pretty interesting. So look into it more if you're curious. So the physical part of setting up a server, where is it located? Back room and all this stuff. All the cabling looks like spaghetti. I get it. Those are all racks. When I get to the full hardware section of this, I will take pictures I have of where I work, where we have all the servers racked and stuff. You'll see all of this. But for example, this guy here, looks like a big old brick fridge. It's not. It's not even an AC unit, believe it or not. This is what's called an uninterrupted power supply. You're like, wait a minute. Doesn't that aren't UPSs like those black big battery things that we have? Some people have at home. Like, yeah, that's the um, you know, God, hold on. This is what they look like if you have one at home. I'll just pull it up a picture like this. And you can plug in your stuff. And what they're for is, for example, there's a power outage. You can still have power for like, I don't know, 15, 20, 30, 40 minutes, an hour, 2 hours, depending on the size you buy, how much you spend. You can turn your stuff off so it isn't damaged. Same thing here. If there's a major blackout, I think they had three of them in this area. This is just a picture I have. And power goes out. These kick in, including a diesel generator, which we have outdoors, part of the building. Schematics is built. Handles that in case there's a big power outage. It kick on and has the servers up and running so we can shut them down properly and so nothing gets damaged. So the location is usually in a back room, has power, right? Has data and cooling. Why you need cooling? These things generate a ton of heat, oddly enough. It's hot. Honestly, whenever I go into our server room at work, it's like 62 degrees. It never gets above it. If it does get above it, I have to call somebody, hey, come here, check the ACs because can't get hotter than X amount of degrees or else things start to fail because, I don't know if you've ever had it where your computer overheats. The first thing it does is shuts itself down to protect itself till it cools off. And that's the same thing a server would do. It would just turn itself off so it doesn't damage itself. It'll do the same thing. But these are the main things you need. I'll cover it more when we get to the unit about hardware, location, and stuff like that. I think it's maybe before disaster recovery, but that's towards the tail end of class, which I'm warning you guys, that stuff can be a little dry. I'll do my best to make it fun and interactive. So now we're going to get to the software install part of it real quick, which we did in the labs, but the labs will be posted by the time this video is up. So this is everything you have to do when you set up one up that is on the network. Well, most servers are on a network, right? But we're going to do this part. We're going to do all of this. Then this part here, this part we do before. This part, I'm not going to read, you guys can read it, it's not that hard. This is what I cover as a unit itself. Then the firewall, we don't have to do much for it because we're not going to do anything crazy. But, for the first part of labs in this unit, you're going to set up this. The network we're going to configure in Unit 2. This is part of Unit 1. This is part of Unit 3. So you'll be fine. Remote access, we do, I think, part of Unit 2. But we'll take care of all this. This is, when you install OS, you do all this. It looks similar to installing Windows. Don't worry. I'm just flying through this because this is just a quick, this is how you do it. This is why you do it kind of deal. In the lab, I go more into detail about the stuff. You will see it if you can't attend either this lecture or the labs. They're pre-recorded for you to look at on Sundays. You still have Tuesday to turn your things in. Please do so. Don't dilly-dally. I know this stuff seems a little easy at first, but it's going to ramp up after week 2. I'm warning you, 3 days won't be enough to get everything done. That's just my warning to you. But reach out if you need help. I'm always around. So security is pretty big nowadays, right? There's phishing emails, you click you won $1 million. Oh, hey, here's your receipt for your order of $350 at, I don't know, Sephora or Best Buy or whatever. Some ports can be opened that shouldn't be open. Drive-by attacks are more like just people trying to grab your information. Trojan viruses and DDoS attacks are just essentially giant ping attacks where they ping something constantly, it can't react fast enough. Like go back in time and look at the Sony hack that happened. They were being pinged constantly and just it was what's called a broadcast storm. So it's things like that. So that's this slide for this part of class. I'm praying it's, yeah, my audio is recording. Okay. So that's this part. We're done here. We're almost done. Now let's go on to the final set of slides for this class section for Unit 1. I'm going to talk about virtualization, which is what we're going to be using in class. So here's what we're going to cover for now. Well, understanding the foundation of modern computing, because let's face it, almost everything now is virtualized. I know this just happened. I harped on it a lot and I'll harp on it now. The AWS crash that happened this past Monday, it's right now, it's Friday, so it's this Monday, was all virtualized. All the servers are virtual. They're not physically air quotes. There's probably like a rack of servers that has a bunch of servers within it. Essentially, when you virtualize something, you're doing what's called a Russian nesting doll. You're like, oh, what's a Russian nesting doll? Let me show you. Russian nesting doll. It's a small one that has like all the sizes of the. You'll see what I mean in a second. Remember, like sizes, like, huh? You're staring at me weird. This is a Russian nesting doll. Doll within a 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 doll. So when you run, this is your physical computer. You're running another digital virtual computer, another virtual computer. So this is as far as we're going to get in the air quotes nesting of it. But that's what AWS is. So this is just saying who I am, what we're covering, and all that stuff. So we're good. You should know who I am, hopefully by now. So we're going to go through the process of creating a virtual version of something commonly applied to servers, storage, networks, and OSs, like the cloud, right? The cloud is all virtual. How many of you use the cloud? I use Google Cloud personally for a bunch of stuff. It allows multiple OSs and apps to run on one machine. That's the whole point. So if any of you, run Windows and want to run Linux, you can make a virtual Linux machine to use Linux. Even though Linux is kind of built into Windows now, you can do what's called a bash command and all that stuff. So why do we virtualize anything? It's to maximize hardware utilization, honestly, reduce costs. Yeah, it's cheaper to have a server that can do multiple things, right? Than have one server dedicated to every little thing. You can virtualize as much as you want. It enables what's called isolation. So, for example, and simplifies testing is where I'm getting to when I say, for example, right now. And improves disaster recovery. It's less to recover technically, but going back to simplified testing, Microsoft patches everything Tuesdays, right? 3 in the morning, the patches come out. Guarantee you before the next version of Windows 11, 23H, whatever they're going to call it. They test all this in virtual environments to make sure it's stable, doesn't crash, and works fine. That's part of it. They can virtualize it. They don't have to dedicate a bunch of physical hardware, like a whole acre of machines. They can have like 3 machines that run, I don't know, 18 virtual machines at a time at different specifications with different setups, and they can test that way. So that's also why. So these are the types of virtualization. Hardware virtualization, you can Amazon's Luna, for example, can virtualize and run games and do things that way. That's why it's done the way. Operating system virtualization I just talked about. You can have virtual machine of Linux. You have a virtual machine of an older version of Windows, even like XP, even though that's what I grew up on. You can do application virtualization, network virtualization. That's a little different. It's more based on your network settings and a port. So one port can turn into a whole virtual LAN is what it's called, where you have a whole network spanning off of one port, which is doable. Storage visualization is more it's used for cloud, usually for backups, transferring data, holding items, things like that, downloading stuff. That's storage visualization usually. So hypervisors are what they're usually referred to as well. Software layers that manage virtual machines. Okay, pretty straightforward. Types, bare metal, VMware, ESXi, Hyper-V, and Xen. Type 2, hosted, VirtualBox, and VMware Workstation. We're going to use mostly VirtualBox. If you are on Mac, the Mac video should be out right out now. I'm making them tomorrow, which is Saturday, but for the sake of this video, when it's uploaded, it should be uploaded with the rest of this, so you should be okay. And when you create a virtual machine, you have to allocate your CPU, your RAM, how much storage you want to give it, and network access, which you kind of have to configure and do it differently. All of this is covered in labs. That's why I'm kind of reading through this as well, but we'll get there, okay? So what are the benefits of virtualization? Well, it's better use of hardware. You get more bang for your buck, right? You can run multiple machines on one machine. It's cheaper. It's flexible. You can run a bunch of different operating systems. It's true. It's scalable. What does that mean? Scalable in the sense of that you can add more virtual machines or remove more virtual machines. How much space do you want? How many items do you want to run at a time? Security, you can isolate a virtual machine pretty quickly. Just pause it, really. And it's off, pause, not doing anything. Backups, yeah, you can take snapshots and rollbacks. It's pretty simple to do it on virtual machines. Not that hard. But part B, common use cases that I mentioned, it's cloud computing, it's a big one, software and testing. Talked about server consolidation. So, for example, at work, we had a bunch of different servers. We had a mail server and all our district mail. We had a bookstore server, we had an application server, and all of them got virtualized. I think, save for the bookstore one because it's just too old, and they're running on something different now. So it's cheaper, right? It's cheaper for us to keep it in the cloud and not worry about it. Well, yeah, it was cheaper until AWS died on Monday and caused a big issue. So pro and con, right? You can't control it; it's out of our hands until AWS comes back. But also, you can do what's called virtual desktops. It gets to the point where you have something called a VDI, virtual desktop interface, where you could go to a computer lab, let's say, and there's only a monitor, keyboard, and mouse, and it just says log in. You log in, it'll create a new temporary workstation, which would be a virtual one that you can use. So, for example, education and training is a common case as well, because that's what's going to replace most labs and most educational areas now. But for Boeing, for example, I use this not to scare you, okay? Don't be afraid of traveling. Most of their pilots get training now on iPads, and they use virtualized cockpits on the iPad where they touch, poke, and pry, which, yeah, it's a virtual cockpit, technically a virtual machine, right? But they're not in a simulator, which is more physical. So it's just that's how they do it. Not the best example, but it's within the same realm. What's another way where they do virtual training? Like fast food places. Same thing. They train that way too. All cloud-based training now. It's different. It's changed a lot. So, what are some challenges of virtualization, though? Performance overhead. What if you make too many machines? You drain your resources pretty quick, right? Licensing can be pretty rough because you have to buy licenses per machine, right? What if you have 8 machines on one machine? You're paying for 9 licenses? That's expensive. Then VM sprawl. What does that mean? You made too many machines. There's not enough resources to go around. You're fighting for resources at that point. You would have too many servers on one virtualized machine or one machine running a bunch of virtual servers. Yeah, it'll bog down with performance overhead as well, but also VM sprawl. But if it can't handle more than 10, you did 12. Too many machines, right? So you have to migrate or move them somewhere else to something else that can handle it. Then you also have security risks. They can be compromised. Yeah, they won't damage that much stuff because it's only one machine. But what if it's a critical virtual machine? So those are things you run into. So here are some common kinds of virtual machine examples I talked about prior. There's VM vSphere, which is now took over from VMware itself. Oracle VirtualBox, which we'll be using. Microsoft Hyper-V, which I've used. It works okay, not bad. KVMs were built into Linux. If you're running Linux for the class, you can use it. It's fine. And Docker, which I know some of you don't know what Docker is. Let me pull up Docker's website. This is what Docker looks like. It's a series of containers. It's coming up. See? Oops, let me get rid of that. It's for developers. You can piggyback and do stuff with Docker. So, yeah, see? Make ADKs, gateways, ADK1. It's just a bunch of different stuff. So here's what's allocated, container usage, build, share, and run applications. So that's what Docker is mostly used for. It's pretty interesting. That's Linux, by the way, right here on the right side. So they're mostly, and it's cloud-based all. See? Whoopsies. Sorry, just other stuff. Nothing crazy, I promise. But it's pretty useful. You have to give certificates and do other things. I know Dr. Sully covers it more than me, but that's also for virtualization. So just wanted to show it to you. So let's move on here. And that's about it, guys, for virtualization. We will get more into it. What did I miss a slide? Sorry. No, we're good. We're good. Sorry, we're fine. So, I covered where physical resources are into virtual ones. That's what pretty much virtualization is. The core is a hypervisor, which is your machine, virtual machine, which is the machine running in the machine, resource management, how much data you want, or how many cores you want to get for your processor, how much RAM you want to give it, how much hard drive space. Its benefits, what's good about it, it's scalable, you can be isolated, and it's the basis of cloud computing. And these are just my references. So, I know I flew through all these slides. It's just me regurgitating or re-saying everything I did on Tuesday because I didn't record. But that's all there is for Unit 1. If you have any questions, email me, PM me on Canvas, or come to office hours. Even though it says you have to have an appointment, you really don't. I'm there on Fridays unless I say I'm not because I have a medical appointment or something else is going on. But normally I'm there 99% of the time. Keep in mind, my office hours are from 7:30 a.m. to 9:30 a.m. If that doesn't work for you, tell me. Message me on Canvas. We can meet probably on a Saturday evening or Sunday evening when I have some time. But guys, also keep in mind, I have a life. I'm not always available, okay? But I'll try to work around you as best I can. Till then, have a good evening. I will see you all Tuesday. Take care.